We're going to move on to the area of a triangle using trig functions. And so far in this chapter, we've talked about the law of sines and found out we could use the law of sines in the side angle case, which is the ambiguous case, and we had to consider both cases when you use law of sines with SSA, but also you could use the law of sines with angle side angle and angle angle side. So there are three conditions that you can use law of sines. Then we moved on to the law of cosines. Law of cosines, you could use it for the side angle side case and the side 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 case. Both of those only have one triangle that you could be working with. You cannot form two triangles given those conditions. From there, we're going to move on to the next section, which is 7.4, and this section exclusively deals with areas of one triangle. You already have one formula for the area of a triangle, which is 1/2 base times height, the area of a triangle. But if you don't know what the height is of a triangle, you can actually find out the area of a triangle using the two triangle formulas that you're going to learn today. So the first one is going to be in a case where you're given a side angle side. Remember, the angle has to be the included angle between the two sides. And if you're given that case, you're going to be looking at an area is equal to 1/2 A times B sine of angle C. You're going to see that we're going to prove that, and the proof is very easy again, but as long as you can see where it's coming from, then you can use the formula. So what I want to do is set it up the same exact way that I set up those other proofs and drop down the height. And so I'm going to have an A, B, and a C. I'm also going to know that I have sides as well. And the area of that triangle as drawn is going to be equal to 1/2 times the base times the height. That's what you know. However, we can also find out what this is if I don't have a height. So I want to use the law of sines on here to figure out what my sine formula is involving the height. So I'm going to say the sine of A is equal to H over C, opposite over hypotenuse. And therefore my H is equal to C sine A, and there's my substitution for my height. So I'm going to come back over here, and I'm going to say the area of a triangle is equal to 1/2 B, and then plug this right in. B times C sine of angle A. And that equation, that formula for the area of the triangle is the same thing for two other cases, given other sides. So the way that you can remember this is the area of the triangle is 1/2 times two sides times the sine of the angle opposite the third side. All of these are different letters. You're going to have a BC and a capital A, or you're always going to have the three different ones, and that's easy to remember. So that's not too bad. The only thing is you got to remember the angle has to be between the two sides. That's one formula that you can use to find area of a triangle. The other formula that you're going to use in this section is called Heron's formula. The proof is on page 356 of your book, but 356 is a proof involving matrices, and it takes a long time. It takes up 2 pages. I'm not going to get into that. So I'm just going to say this is the formula. Know that you use it when you're given all 3 sides of a triangle. The area says that it's going to be equal to the square root of the semi-perimeter. Semi-perimeter is equal to half of the perimeter. So the perimeter of a triangle is you just add up all the sides. The semi-perimeter is add up all the sides and divide by 2. So all you're doing is finding the semi-perimeter and saying that's what my S is, and then you're just going to subtract A, B, and C off of that S and multiply those together. And what I want to do is one problem using both of these formulas, and then that'll be it for the section. So 2 formulas, we're going to use them both, and again, the key on knowing when to use each one is to know if it's side, 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 or side, angle, side. Side, side, side is where all the sides are given. Let's go ahead and look at this one. This is number 8 from your textbook. It says, find the area of a triangle. Find the area of a triangle when you know that you have an angle B, an angle C, and a side A. Well, you're given angles and sides, so you know you want to use the trig function, the formula for the area of a triangle. But you've got to make sure that things match up. I do not have 2 sides here. I have 2 angles and a side. So I need to get a side first. If I get the side, then I can use that side and use the formula. So this is going to be a 2-step problem in order for me to get what I want. So what I like to do is just do a quick drawing to see what we're looking at, A, B, C. So I don't care what if this is not drawn correctly. B is 57 degrees. C is 31 degrees. And then you have your A. So at this point, the first thing that I want to do is recognize it's an angle side angle, meaning you can use law of sines to get one part, and then after that you can go ahead and use the area formula for the triangle. So to find the missing side, you just take 180, subtract off both of those angles, and you're going to end up with 92 degrees. And then what you want to do is go ahead and use the law of sines, and let's say you just want to calculate what B is. So it's going to be B is to sine B as A is to sine A by multiplying both sides by sine 57. You should end up with B is approximately equal to 6.126. And now what I want to do is go ahead and use the formula for the area of a triangle. So, so I want to use B and A. So it's going to be the formula, area of the triangle is equal to B times A, because I just got B. I need to use B. B times A times the sine of angle C. All right, and it's 1/2 times that. Equals 1/2. Let's see, my B is going to be 6.126. I have that number in my calculator. Times my A, 7.3. Times the sine of angle C, which is 31. So I'm going to start with what's in my calculator and just put times 0.5 times 7.3 times the sine of 31. And end up with the area is equal to 11.52 meters squared. You're squaring the units, you're squaring the M, you're not squaring the number. So notice where I'm putting that square, right on my label. So that's one way to show the area of a triangle. Now, you're not always going to have to use the law of sines. If you're given a side, an angle, and a side, you can go ahead and just plug those into this formula and work through it. So it could be a one-step process. The second one is going to involve Huron's formula. Huron's formula is going to be given where you're given three sides of a triangle. And the three sides of a triangle in this one, number 18, are going to be A is equal to 8.32, B is equal to 6.23, and C is equal to 3.45. Given three sides, you automatically think Huron's formula, it's that square root equation. So area of the triangle is equal to the square root of Now, in terms of the tests, I will give you the law of cosines formula on the whiteboard, which will be for the side length and for the angle. So those two different forms. I'll put it in one form, not three of them listed out, but one. And I'll also give you this Huron's formula. You'll have to know what S is, but I'll write that down on the board as well. Everything else you're going to need to know. So first thing I do is calculate S, the semi-perimeter. S is going to be adding up all those numbers and dividing by 2. You add up all those numbers, you divide by 2, you're going to end up getting 9 as the semi-perimeter. Then I go to here, and I'm going to actually put in the numbers. So it's 9 times, and then I'm just going to take 9 and subtract off A. 0.68 times. And then I'm going to go back to 9, subtract off B. And then subtract off C. So I want to do this all in one shot. And you're going to end up getting 9.70. And it would be whatever units you have squared. Okay, that gives you an example on using the two new areas of the triangle. Tomorrow we're going to get into vectors. And again, the last two sections should be relatively easy compared to the first couple.